a transformed graph. You found the general mapping. You took the critical points at the sine and the cosine curve. You put it through the general mapping. You found new points, and then you graphed these points. Okay? So very important concept. There'll be a couple questions just like that on your test. Today we're going to be doing where you're given some information and you want to come up with the equation. Okay, so whether you're using the sine curve or the cosine curve, we'll be using the same parameters. So the task today is to determine the A value, the C value, the D value, and the B value given some information. Okay? So remember, the most common mistake people make is that the A value is not the amplitude. The A value gives you the amplitude when you take the absolute value from it. The C value is not the period. The C value gives you the period. Okay? The D value is the phase shift, and the B value is the vertical translation. And the A value, the C value, and the B value are the same whether you're using the sine curve or the cosine curve to represent the graph. The only thing that's going to change is the phase shift, because the sine curve and the cosine curve are just phase shifts of each other anyway. Okay, so we're going to be asked to identify the A, the B, and the C, and the D values. And how we're going to do that is using the following formulas. I'm going to use capital M for the maximum value on the graph, and I'll use little m for the minimum value. So to identify the A value, all you have to do is identify the largest value, subtract off the lowest value, and divide by 2. It's fairly straightforward. To find the B value, you take the largest value and add it to the smallest value and divide by 2. So that'll give you the A and the B value. Then the C value can be found using the relationship that the period is equal to 2 pi divided by the C value. So in this case, they're going to give us the period, and then we're going to rearrange the formula to solve for C. Okay? Because remember, the period is not the C value. The C value gives you the period. And then the hard one for most people is identifying the D value. The D value depends on which graph you're using. So if you're using the sine graph to represent, or the cosine graph. The sine graph, we know, looks like this. And the cosine graph, we know, looks like this. The same value there. So what we need to do is to figure out where the starting point for the sine curve, if we're using the sine curve, we have to figure out where that point is and how far it's moved away from the y-axis. Okay? So how we're going to identify that point is we're going to look for the halfway point, because this point is halfway between the maximum value and the minimum value. And then we're going to look for when the sine curve starts to move up and then down again. And with the cosine curve, it starts at its highest value. So we're going to identify that point. And you'd be like, what's he talking about? I'll show it to you when we do some examples. Okay, so we'll make it easier to understand. Okay, so we'll start off with this one first. A sine function has a maximum value of 8 and minimum value of -2, a phase shift of pi over 4 units to the left, and has a period of pi over 3. Write the equation for that function. So I want to come up with a transformed sine function. So I need to identify the A, the C, the D, and the B parameters. So the A is equal to the maximum amount, subtract off the minimum. So the highest value, subtract off the lowest value. So the highest this function ever gets is 8. Subtract off the lowest it gets, which is -2, and then divide by 2. So that becomes 10 divided by 2, which is 5. So that's my A value. My B value is 8 plus -2 divided by 2, which is 6 divided by 2, which is 3. Any questions on identifying the A or the B values? Because it's pretty much straightforward. You just have to remember these formulas. the C value can be found by using the relationship that the period is equal to 2 pi divided by the C value. In our example, the period is pi over 3. So I put pi over 3 in place of my period. And then I just have to solve this equation for C. Because it's two fractions equal to each other, it's really a two-term proportion. I can cross multiply. So C times pi is pi C. 2 times 3 is 6. And then we have our pi. Divide both sides by pi. And it turns out my C value is 6. Does it make sense? Okay, so the period is pi over 3. The C value is 6. Two different things. And then my D value, it says, is pi over 4 units to the left. So my D value is negative pi over 4. So I have all the information I need, and I can substitute it into my transform sine curve. So the A value is 5, the C value was 6, the D value was negative pi over 4, so when I substitute it in, the two negatives make a positive. And then my B value was 3. So that's an equation of a transform sine curve, where the highest value on the graph would be 8, the lowest value would be negative 2. If you moved over negative pi over 4 units to the left, and then the period would work out to be pi. Straightforward? Okay. So let's just try it with the cosine curve, which is really the exact same thing, but really in this example, I wanted you to understand that the period does not always have to involve pi's, and the phase shifts don't always have to involve pi's. Okay? So same concept. The only difference is we're using a cosine curve instead of a sine curve. So my A value is the highest, which is 3. Subtract off the lowest, which is negative 1. So 4 divided by 2 is 2. My B value is my highest value added to the lowest value, divided by 2, which is 2 divided by 2, which is 1. My period is equal to 2 pi divided by C. So in this case, it tells me that my period is 2 radians, not 2 pi radians, just 2 radians. Okay, so I put in 2 for my period. I can make it look like a fraction by putting it over 1, cross multiplying. I get 2 times C is 2C. 1 times 2 pi is 2 pi. Divide both sides by 2 to isolate my C. And my C works out to be pi. Make sense? And then my D value is my phase shift, and it told me that it's 1 unit to the right. So it's positive 1 unit. So I take all that information and I substitute it into my transformed cosine curve. So A was 2. My C value was pi. My D value was positive 1. So when I put it in, it becomes a minus 1. And my B value was 1. And so that example shows you that, well, I'm using a cosine curve, which really didn't change anything, but I wanted you to be aware of the fact that the period doesn't necessarily always have a pi in it, and the phase shift doesn't always necessarily have a pi in it, okay? So here it just happens to be 2 radians and 1 radian, okay? And then my C value has a pi in it. Any questions on that one? Okay. So now we're going to do the exact same thing, but we're going to get all the information from a graph. So I'll just make this a little bit bigger so that we can see it and get some information first before we fill in our A, B, and C values. Now this one says determine the equations Okay, so we're going to determine the equation of the sine and the cosine transformations that will give me this graph. So in order to do that, before we start, let's just read off the graph, what the maximum value is, what the minimum value is. So the maximum value here is at 2. The minimum value, the function of it gets is -4. You guys know where I'm getting that from? The period. What's the period of this function? Pi. How did you get that? Okay, so you used the original cosine curve, right? Okay, so what Caitlin did is said, okay, the cosine curve is here. So the cosine curve starts at its highest point, goes down to its middle, down to its lowest, to its middle, to its highest point again. So for it to start and finish, it started at 0, ended at pi. So the period of this guy is pi. Does that make sense? Okay. So you would just look for the cosine curve or the sine curve. It doesn't matter, right? If you're using the sine curve, you can figure out the middle point, figure out where it ends up, and then figure out that distance. Okay, but it's a little bit easier to use the cosine curve. Okay, so now that we have that information, I can figure out the A, the B, and the C values, because that's the same for the sine and the cosine curve, so let's do that. So my A value is the highest point, subtract off the lowest point, divided by 2, which is 6 divided by 2, which is 3. My B value is the highest point, added to the lowest point, which becomes a negative, divided by 2. So that's 2 minus 4, which is -2, divided by 2 is -1. And then my period is pi. And we know that the period is equal to 2 pi over the C value. Cross multiply, I get pi C is equal to 2 pi, divide both sides by pi, and it turns out my C value is 2. Make sense? Ha. Have to. Right. So I'm not, the other examples I gave you the period. Okay, this one here off the graph, you have to figure out the period. Okay? And then once you figure out the period, then you have to use that to figure out the C value. Okay, so it doesn't matter if I'm using the sine or the cosine curve. These values are going to be the same. So I'm just going to write them in because we're going to do it for both of them. So y is equal to 3 sine. My C value was 2. And I don't know my phase shift. I'm going to figure that out in a second. And my B value is -1. So I'll do that for the sine curve. And for the cosine curve, everything's the exact same thing. Again, the only thing that's going to change between the two curves is the phase shift. Okay, so now what we have to do is identify where the sine curve starts. So if I go back to here, remember I said that the sine curve starts in its middle of the graph. So you have to figure out where the middle value is. So you take the highest point, and the lowest point, divide by 2 to get the middle value. So let's figure out where that is first of all. So what value is halfway between 2 and -4? It's halfway between -1. So here's -1, okay? So now, here's -1, so this is where the sine curve are. Would this be the starting point for the sine curve? Why not, Kyle? You're shaking your head. It doesn't matter where it is because it's been moved, right? Because what's happens is, going way over here, is this point, which is the original guy, he ends up somewhere else. So that's why I'm trying to figure out where that point ended up. So I know David told me it's -1, which is perfect. Why isn't this the starting one for sine curve? What does the sine curve do after its starting point? Does it head up or head down? Out? It goes to its maximum. Is that guy going to its maximum? No, it's going to its minimum. How about this guy here? It's going to its maximum. Okay? So here is my starting point because it goes up to its maximum, down to its middle again, down to its lowest point to its maximum. So there is my sine curve. Do you guys see it? Okay, so what I need to do is figure out how far this guy has moved away from the from the y-axis. You can't see that, but that's -pi/4. Okay, so if it's -pi/4 inside of the bracket, it'll be positive. So I'll just draw that in. So if you're looking back at it, you'll see that's where my green guy started. My cosine curve, it starts at its highest value, right? And if you look back at this guy does start at its highest value. So it goes all the way down, ends up again. So this guy doesn't even have a phase shift. Okay, so if I wanted to rewrite that to make it look prettier, I can write it. Does that make sense? Okay. So after the, some of the ones in the guide aren't the best because you have to kind of estimate some of the values. So I have one you could practice for graph ones on this piece of graph paper, and you could figure everything out. I'll give that to you after the lesson, just as a practice. Okay, the last thing we're going to do is solving word problems. So you'll be responsible for solving word problems very similar to this. And I feel the easiest way to solve a word problem is to draw the graph of it. Once you've drawn the graph of what's going on in the word problem, then you end up with solving a question like this. Okay. So a stone is lodged in a tire that has a diameter of 8 centimeters. So I'm going to draw in my tire. And I know that the diameter is 80 centimeters. The tire, here's my stone at the bottom, because it tells me that the stone is at the ground level at 0 time at the starting. I want to determine a model that represents the height of the stone above the ground at any time. Okay. So the tire takes 24 seconds to complete run rotation. So for this stone to end up on the ground again, that takes 24 seconds. So let's graph the height of this stone above the ground at any time t. Okay, so the first thing we need to do is identify the period. Remember, the period is the time it takes to complete its cycle. What's the period in this example? Huh? It's the time. Yeah, so how long does it take to go around? 24 seconds. So the period is 24 seconds. So just like with the sine curve, right? We always use this value, then halfway in between, halfway in between, halfway in between there. So we're just going to label the axis accordingly. So halfway would be 12, halfway between there would be 6, halfway in between here would be... Make sense how I labeled the x-axis? So that's my time. And this is the distance above the ground. Okay. There's time 0. At time 0, the stone is on the ground, so the height of it is 0. At 6 seconds, what's the height of the stone? Above the ground. There's the graph. So if you're kind of struggling with that, let's draw in these values. So what I've done is I divided this into 4 separate sections, right? So halfway through at 12 seconds, it would be here. 6 seconds, it would be here. 18 seconds, it would be here. 24 seconds, it's back down to the ground again. Okay? is how much? So a quarter of 80. So picture this, right? Here's the stone, right? He starts, well, not he, she, maybe, I don't know, stone. Starts to go up like this, right? And then at 6 seconds, it's this high above the ground. What's that height above the ground? This height right here, what's that? 40, exactly. Okay? So here, it's 40 centimeters above the ground. And when it reaches the top of the tire, how far is it above the ground? 80. And then it falls back down to 40, and then back to down to the ground again. Does this make sense how this represents the height of the tire above the ground? So if you want to, you can join it up in a nice smooth curve. And this is the graph that you want to represent. So because it doesn't matter, and I didn't tell you to use the sine or the cosine curve, it doesn't matter which one. Let's figure out the A, the B, and the C values, because that's going to be the same for any one you use. So the A is the highest point, which is 80. Subtract off the lowest point, which is 0, divided by 2. So the A value is 40. The B value is the highest added to the lowest, divided by 2, which also happens to work out to be 40. The period, right, is 24 seconds. So 24 is equal to 2 pi over c. That allows me to determine my c value. Cross multiply, I get 24c is equal to 2 pi. Divide both sides by 24 and simplify that fraction. And the c value works out to be pi over 12. Again, I can use the sine curve or the cosine curve to do this. So I'm going to do it for both of them, just so you have both answers in your notes. So the sine curve is equal to 40. The sine, the c value was pi over 12. X, I don't know the phase shift. I'll figure that out in a second. And my b value is 40. My cosine is 40 cosine pi over 12 x. Again, I don't know the phase shift. I'll figure that out in a second. Plus 40. Okay, so I'm just going to refer to the points as the first one being 0.1, then 0.2, 0.3, 0.4, 0.5. Which point 1, 2, 3, 4, 5 is the starting point for the sine curve? 2. Excellent. Okay, so this is halfway between. This is where it starts to head up to its maximum. So this right here is my starting point for my sine curve. How far away has it moved from the y-axis? Okay. That's
from the y-axis.
Right, 6. So minus 6. Where's the starting point for my cosine curve? Which one? The third one. And how far away has that moved from my y-axis? 12. So either one, the green one or the blue one, represent the graph of the red graph. Either one is going to work. Okay. There's a third one I could use. Well, there's an infinite number of ones. But how can I use the cosine curve if I didn't even want a phase shift? Yeah.
You could just make the a value negative.
Awesome. Okay, so this right here is the cosine curve flipped over. So I could have used that. All three of these equations represent that graph. They're all correct. On the test, I'm not going to say which one to use. You give me whichever one you find easier to give me. Okay? And then the last thing you're going to be responsible for is to figuring out the height of the stone at a certain time. So determine the height of the stone after 0.75 seconds. So all you would do is use your equation. You do not have to give me both, right? You just give me one of these guys. Use whichever equation you came up with. And just substitute that time into your equation for x, the only thing you have to do is make sure your calculator is in radians. Okay? Because if it's in degrees, it's going to give you the wrong answer. So your calculator must be in radians. And if you've done it correctly, and I've done it correctly, it should be 0.7689 centimeters above the ground, which makes sense to put it in my graph, right? Because it's barely gone a second, so it's barely off the ground, so it's about here somewhere. Okay? Any questions on this? Okay. So I'm just going to stop this.